Welcome everybody. This is Apprenticeship in Workplace 11 and we're talking about the booklet for Algebra 3 ratios. So we're looking at the algebra and the different styles that we need to sort out, dealing with questions that are ratios, and then also looking at some word problems, how to set them up, how to be successful, and then also how to use your intuition to solve these. And then we'll go through some of the questions in the booklet to help you get going. So yeah, maybe get ready to take some notes. Alright, so let's have a look at a simple type of question that you'll see when you're dealing with ratio problems. I call this a ratio equation, or basically a fractional equation. You've got one fraction over here equaling one fraction over there. So how do we manage that? Well, if you recall the philosophy of algebra, I'll write it up. Okay, so remember what a philosophy is. It's like a style of thinking, or it's a style of getting things done. Kind of like a culture or something like that. So the philosophy of algebra, the philosophy of algebra has three parts. First, isolate. We have to isolate our variable, or isolate x, or whatever variable we're using. We do that by eliminating the parts around it. And then we have to balance, right? So what we do to one side, we have to do to the other. Okay, so if we think about this problem here, here's what I have to isolate. Stopping it from being isolated is this 12 on the bottom. And this sign here in the middle is divided by. This says x divided by 12 is equal to 7 divided by 3. And so some of you could probably already guess it. The answer is 28. But if you couldn't guess it, don't try to guess ahead. See if you can do the algebra properly. So, okay, in order for me to isolate, I have to be able to eliminate the 12. So how do you eliminate a divide by 12? What's the opposite of divide by 12? Multiply by 12. So let's see what that looks like. Okay, so I'm multiplying by 12. I write 12 as 12 over 1 just to make it easy to see how things in the fraction cancel out. And as you can see on the left-hand side, the 12 on top of the fraction cancels out with the 12 on the bottom of the fraction, and just leaving the value of x. As you can see, right, the 12s cancel out on the left-hand side, and the x is left by itself. And then on the right-hand side, what I times by 12, well, I gotta go 7 times 12, right? 7 times 12, and then divided by 3. And 7 times 12 divided by 3, which we see in this simplified version. So you calculate that on your calculator. 7 times 12 divided by 3 is 28. Okay, 28. Alright everybody, so here's another one. Now this one has the x on the bottom of the fraction. So isolating it is a little harder, it requires an extra step. And, well, when x is on the bottom, there's a bunch of ways to do it, but here's the quickest way that I know how to do it. Remember, the rule of algebra is you have to balance, right? What you do to one side, you have to do to the other side. So I can flip one side to get the x on top, and then I flip the other side to keep balance, right? What you do to one side, you do to the other. And that gets the x on top of the fraction, and that makes it a heck of a lot easier to work with. So let's see what that looks like when I do that. Right, so I'm going to flip both sides. You have to do it to both, not just one. Okay, so that's what it looks like when they both flip. And now it's just like the last question that we did. X is on top, is being divided by 18. To eliminate or cancel out or divide by 18, yep, you guessed it, you have to times both sides by 18. Let's see what that looks like. Right, I show it as 18 over 1. You can show it as whatever, but yeah, 18 over 1. And now let's do our cancellations. Okay, so I cancel out the 18s, and I'm left with x just on one side, and that's nice. I got it solved for it, it's isolated. And then everything else on the other side, well, I got to calculate. 44 times 18, get an answer for that, and then divide it by 24 should give you a value of 33. And really, these are the two main algebra styles that you deal with when you're working with ratios. And ratios is the most common math algebra that you wind up doing in real life. In fact, this is probably the most important math that you'll do all year, especially in algebra, because life is mostly about ratios. So let's have a look at a couple of word problems where I help you set up the algebra so that you can find your answer. One of the most common places you find ratio work is in the nature of recipes. You open up a recipe book, any kind of cookbook that have a recipe, it'll give you all the ingredients, and it will say, okay, and this feeds, well, in this case, it feeds 5 people. But let's say we want to feed 9 people. How do I adjust the recipe in order to meet that many people? Well, it's not so clear. So, in this case, it takes 350 grams to feed 5 people. How much will it take to feed 9 people? Let's look at a process that you'll get it right all the time. It's called a ratio equation. And I'll set up a little T-chart for you. You'll never go wrong if you use this method dealing with ratio work. So, let's have a look. Okay, so I'm setting up a little chart that explains the theory over here and what it looks like in practice over there. So our first job is to set up what I call a ratio equation. I'll show you what that looks like. Okay, so I've set up something called a ratio equation, and I basically use letters to denote the details in my problem. And I've got flour, or how much it weighs, so I'll use F for flour and P for people. And the important thing is that when I'm setting it up, I have to keep the letters the same. So if I've got F and P to start, then I need F and P in the second part of the equation. They have to have the same order. Doesn't matter which order, as long as they have the same order. So I've set up the letters, and now I plug in the numbers. Let's see what that looks like. So from the recipe, I know that 350 grams feeds 5 people. And I want to figure out how many X grams feeds 9 people. So this is what I call a ratio equation, and these little colon symbols mean the word 2. And what we can do is we can convert those to fractions, because all ratios are just basically fractions. So now we can convert it to a fraction, which we know how to solve, because we're smart. Let's have a look. The first part of the fraction, or the first part of the ratio, becomes the top of the fraction. The second part of the ratio becomes the bottom of the fraction. So you just do the same to both sides, and while we have a ratio equation with fractions, we just solve 2 of them. In fact, this one is nice and easy. X is on the top over here, right? So I don't even need to flip it, right? X is on the top, so I flip both sides. Here's what it looks like when we solve it. See if you can get the answer. Right, so I got a times by 9 to both sides. Okay, so that the X divided by 9 will cancel out. And then I just got to keep track of what's going on the other side. So let's have a look. Okay, so the 9's cancel out. On the other side, I have to go 9 times 350 divided by 5. You do that on your calculator, you get 630 grams. And that lets you know how much flour to use, right? Do you have enough? Do you need to go to the store and buy more? You know, it lets you know how to adapt it for a different situation, given that they are proportional or they're in ratio with one another. So let's have a look at one more question, and then we'll do a question from the workbook. And then I'll say sayonara, because you guys will have the opportunity to practice this for the week. Alright, so here's another example. I have a walking route that I do at nighttime, and it takes me about 18 minutes to walk the full 4 blocks. They're kind of long blocks. So let's say I have 45 minutes of time that I can devote to a walk at nighttime, and I want to figure out how many blocks it takes me to, how many blocks I can walk in those 45 minutes. So I can think of the question like this. It takes 18 minutes to walk 4 blocks. How many blocks can be walked in 45 minutes? Well, my friends, the same process. You set up a ratio equation, and then we convert them to numbers, and we convert them to fractions, and then we solve. So let's go through the process without the T-chart, see if you can do it. Okay, so I'm setting up a ratio equation. I use my letters, right? I'm going to use T for time and B for blocks walked. So time to blocks is equal to time to blocks. Remember, the letters have to be the same order on both sides of the equal sign. Okay, so they are, so that's good. Next step, fill in the numbers and figure out where to put the variable. What am I looking for? I'm looking for the number of blocks walked. So my B is going to be where I see an X value. Let's see how it works. Okay, 18 minutes for 4 blocks, 45 minutes for X blocks. Okay, so convert to fractions and solve. Okay, so there's the fractions. Do I have to flip? Is X on the bottom? Yeah, X is on the bottom. So I have to flip both fractions, not just the one on the right. Okay, so I flip both fractions. Now it's a matter of, well, X is being divided by 45. So the opposite of divide by 45 is to times by 45. I got to do it to both sides, and I got to calculate it out. So let's get the final answer. Okay, so I have 45 times 4 divided by 18. And if I calculate that out on my calculator, what do I get? It rhymes with Big Ben. Yep, 10. 10 blocks, right? Boom. So this lets me know, okay, well, if I'm going to do a 45-minute walk, I got 10 blocks to walk, so I better, plan my route carefully and don't, overshoot it and walk longer than the time I have and maximize the amount of time that I've got available to use. Simple, small things like that is what ratios are built on, and that's really what algebra started as. It's how to figure these little details out. So let's stop with the lesson. I still want to go through some of the items on the book. We'll look at that, and then I'll let you have some time to get your work done. Okay, so here's the very first question from the very first item on the booklet, number 3. 2 over 5 is equal to 12 over n. And some of you guys can guess it, right? The answer is, what, that's 30, I think? So let's see how it plays out if we do it properly. Okay, so I have to multiply both sides by 12. I have to flip both fractions, right? Because n is on the bottom. And then I got n divided by 12, so I have to multiply both sides by 12 to cancel out the 12, like, just regular algebra, what we've been doing. So let's see how it cancels and what our answer is. Okay, so I'll cancel the 12, n is by itself. Then I got to calculate what's on the other side over here. So 12 times 5 is 60. 60 divided by 2 is 30. Yeah, there it is. Bada bing, bada boom. Right, so there's our answer, and then if you look at the page, and letter I is equal to 30. So you go on the top of where the answers are on that page, and you look for every time you see a 30. So there's one on the first line. I think that's it. Yep, there's only one. It's on the first line near the end, and then you just put the letter 30 in. You complete all those, and you get your answer to your joke. Easy peasy. Okay, so let's have a look at page 2. Very first one, negative 1/2 is equal to g over 8. Let's go through the process. Okay, negative 1/2 is equal to g over 8. There it is. Is the variable on top or on bottom? Yeah, the variable's on top. G is above the 8. So do I have to flip the fraction? Heck no. G is already on top. Don't need to flip anything. So now it's easy peasy. G is being divided by 8. So we have to times by 8 to both sides to cancel out. Right? Times by 8 to both sides. 8 on the left hand side. On the right hand side will cancel out, and then what we'll have to do is just keep track of the other side. See how it plays. Okay, so cancel out the 8 there. On the other side, I got 8 times negative 1, all divided by 2. So negative 8 divided by 2. Don't use your calculator. You can do it. It's negative 4. So we got an answer of negative 4 for letter G. So you go find negative 4 on the letters, and you put the letter G on it. So I think it's up near the top there. You put a letter G in its spot. And you do it for all of them there, and you get the letters, and in the end it will spell the little joke. Alright, the first part of page 3 says, write the ratios or the fractions in lowest terms. Now remember, lowest terms just means if there's anything common after you put it into fractions, you cancel them out. So we write this ratio, 4 to 12, as a fraction, and then see if we can simplify it. Let's see how it goes. Right, so we write it as a fraction, and then can 4 and 12 both be divided by the same number, or any number do they share? They do. Do you know what it is? Well, so a lot of people might have said 2, and 2 is one number, but it's not the biggest number they can both divide by. In fact, both of them can be divided by 4. So, when I divide both the top and the bottom by 4, I'll get my lowest terms. Alright, 4 divided by 4 is 1, and 12 divided by 4 is 3. So 1/3. So you go on the side, and you look for 1/3, which is number 5. And so number 5, every time you see a 5 on the bottom of the screen, on the bottom of the page, you put the letter S. See? Oh, where are we here? Our answer, right? Letter S over here was 1/3. So 1/3 over here, where is it here? There it is. It's number 5. So down at the bottom, every time you see number 5, where have we got a 5 here? There's one. There's another one. Maybe there's a couple others, who knows. But when you see a number 5, you write in the letter S. And then you do them all and you get your little joke. Now some of them get a little bit challenging at the end. And I want to do the very, very last question of this here with you before I sign off. Alright, so the very, very last question on the in the booklet says, the Boston Bruins hockey team played, set a record by winning 57 games, 7 ties, and 14 losses. So I wrote that up here, right? 57 wins, 7 ties, 14 losses. And they want you to find the ratio of games won, so W, to games played. Well, how am I going to figure out how many games they played? Maybe if I add up all the wins, losses, and ties, that should equal the number of games played. Yeah, why don't we do that? Okay, let's do that. Alright, so they played 57 games with 7 ties and 14 losses. If you add all that up, that gets you 78. So now we know how many wins they had, and we also know how many games they played. So we can fill in our little ratio over here. Let's see what we get. Okay, so 57 wins to 78 games played, right? I can write it as a fraction, 57 over 78. And if you look down on the answer key, you won't find it. So did we do something wrong? Is there more that we could do? Does anybody know what to do? I do. We need to simplify the fraction. Can 57 and 78 both be divided by the same number? Well, they can't be divided by 2, because 57 is an odd number. So although it would work for 78, it won't work for 57. What about if we divide by 3? What happens when we divide 57 by 3? There it is. 57 divided by 3 is 19. 78 divided by 3 is 26. We have to simplify it down, right? This kind of last worksheet is about simplifying your fractions a little bit. So what letter is that, or what number is that? That's number 15. And number 15 gives you the letter C. So in all the spots at the bottom, every time you see a 15 down at the bottom, there's 1, 2, there's 2 at least. There's at least 2. You can put in the letter C. And that's that. So that's your booklet, okay? And yeah, I'll give you about a week to do it. And we'll, yeah, I'll let you guys go and enjoy the rest of your time. Take care, guys. Bye.